So welcome everyone to another edition of our foundations training for the requirements development and management for business data analytics, the language of data. I'm Richard Frederick. I'm your host for the next 30 minutes. Some of you know me, you've been out here for the sixth session. And for those of you that are new, welcome to our little group. This slide is always the first slide in the presentation. And I always, a couple things before I start, and then I'll start. I want to call out the IIBA Tampa Bay, which is a great organization that has kind of hosted this for us, or at least for me, for the last 6 sessions. And if you get a chance, please look them up on LinkedIn or on Meetup and join us. It's a great group. We have a lot of members and a lot of activities. So please feel free to join our little group here in the Tampa Bay area. I'm actually north of Tampa Bay. I'm in Lake County, for those of you that know Florida. But anyway, the other housekeeping thing I got to make sure I tell you guys is there will be a PDF and a YouTube video that I will send out to everybody after I get the YouTube video uploaded. I'll send out links, but you need to send me an email. Please send me an email. Cannot hear. Okay, one moment. Can you guys hear me? Put a yes if you can hear me. Okay. All right. All right. So Galaxy S9, I think it's something on your end. Hang on, they can't hear me. Oh, okay, you can hear me now. Okay, good, 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 good. All right, excellent. All right, excellent, excellent. Here we go. So, make sure I got everything going. All right. So what we're going to talk about today is something from the International Council on Systems Engineering. And I'm going to do a little veer and talk more about the business side of business analysis as opposed to just the technical side of business analysis. Oh, sorry, I sort of jumped. The reason I always start on this slide, for those of you that are new to the presentation, is that I'm trying to show you that if you're struggling with requirements, you're not alone. The reality behind requirements is that they're very difficult. And the way I can prove that is that all of these groups are always trying to work on perfecting what we do as analysts in the world of requirements. And nobody really has an answer for all of it. People ask me all the time, what's the right way to do it? And I have to say, I have no idea. There's all these different ways, as you can tell, from all of the different items. This class specifically that I put together is a traditional requirements class, but the difference is that it focuses predominantly on business data analytics, which is the language of data. And the reason I did that was because as an instructor, I've been teaching business analysts, thousands of business analysts now, for about 15 years. And the curriculum, the traditional curriculum, focuses predominantly on product and process, which is great. Nothing wrong with that. Everybody's going to have to know product and process. But with the advent of the digital transformation, which is really about data, I felt that it would be really useful to have a requirements class that was specifically about data. In particular, business data analytics, which comes, that term is actually, I kind of pulled that from the IIBA, but it's an old concept. It's not anything that's new. We teach, or I teach, something known as the CRISP DMML, which is the cross-industry standard process for data mining and machine learning, or dashboards and robots. And that approach is the same approach that the IIBA has in their certified business data analytics. So it's complementary. It's nothing is unique. And everything that I teach is open source. So feel free to pass this on to whomever you think might need it or can use it. And at the end, I call this a train the trainer. My goal is for you to take something that you learn from every one of these sessions and go teach somebody else. It's the best way to learn it, is to teach it to someone else. So feel free to pass that information on. Really quick, a little bit about me. I have a partner, Rob Stokes, who's online today. And we started a software company back in the 1990s. We built software robots called Autobots, and we thought the world would be very different than it is today. But it didn't really work out that way. But just the same, so we started out in that business, software integration plus workflow automation, and we were very focused on how to build robots, which is really about data. That's the whole idea, is that it's all about data. And I thought by the year 2005, everybody would be completely automated, and I was wrong. So, and we're still not totally automated yet, which I guess is a good thing if you're a human, but we're moving in that direction. And so the idea is to kind of give people some background on how to look at things from a data perspective through the eyes of a business analyst. Okay, so this is not, we're not about trying to make you a data scientist. You know, those subject matter experts are always going to exist. You don't have to become a data scientist to be a good business analyst. You just have to understand what a data scientist does. I always tell everybody a good business analyst is really a jack of all trades and master of none. Your skill set is your ability to communicate effectively with other subject matter experts, not to become a subject matter expert in everything. That being said, the fact that you're going to talk to lots of different subject matter experts is going to make you very knowledgeable about a lot of things. So I'm very broad, but not super deep, unfortunately. I've learned all kinds of things, and as an analyst, our job is to ultimately make the institution run more efficiently. And there's a joke about this that goes all the way back to the 1950s from IBM. So I want you to think about this in terms of where we are today in the year 2020. This is 1950. The joke was, the company of the future has a man and a dog. The man is there to feed the dog, and the dog is there to make sure that the man never touches the machine. So the idea was, back in 1950, that eventually we would have companies with no people. And that's kind of what the role of a business analyst is, although no one wants to admit that, is that we're there to help automate inefficiency out of the institution. And you can't really automate inefficiency. You have to make something efficient first and then automate it, but that's another story for another day. What I wanted to do today was I wanted to talk a little bit about the business side of what we do as it relates to requirements. So again, in each one of these foundational webinars, the goal, the overview is to seek to understand. And I think that that's probably the ultimate way of thinking about what you do as an analyst, is that we're always seeking to understand, that we're looking for information. And I mentioned last week, I said probably the most important skill is the one that I can't teach, which is you need to be curious as an analyst. Your job as an analyst is curiosity. If you see your job as an order taker, where you're just taking information from the business side and then turning it over to the technical side, your job will probably go away because you're a very expensive resource to do just that. So you have to do a little bit more. You have to be curious and really begin to understand how all the pieces fit and operate within the machine, which is the institution where you work. The business side of that is called accounting. And it's really interesting as someone that trains business analysts, because usually when students come to class, they're either really strong on the business side and they have to kind of learn the technology side, or they're very strong on the technology side and they have to learn the business side. And this job really is a 50-50 job. It's business and technology. And the business side is accounting. And people always look at me like, what? I said, yeah, this is an accounting course. And whoa, wait a minute. I thought it was a technology course. No, it's accounting. It's half accounting, half technology. And the reason I use the word accounting is that accounting really means the language of business, regardless of what your business is. So you could be in the business of government, the business of a nonprofit, the business of entertainment, the business of product, whatever your business is, there's going to be an accounting system. Because without the accounting system, the institution does not operate. That being said, in this particular webinar, we're going to talk about viewing requirements as parts, discrete intellectual property, a reusable inventory of parts. And with that as kind of the basis, then we're going to talk about the INCOSE rules for writing requirements for inventory. an inventory of parts. So it's not just, oh, okay, we're not just writing requirements, but there's a reason, there's a perspective that we're going to give you to think about as you're going through your process. And then lastly, I'm going to touch on a product called QVScribe that is really powerful for those of you that are working on trying to build standard requirements inventories. So, I mean, it does a lot of things, but that's kind of where I look at it from. So let's talk about just requirements and how they work as discrete intellectual property. So I go in and I always talk to students about parts. And one of the things that I'm always trying to train analysts is to see numbers, that everything that you see around you at some point lived as inventory in somebody's warehouse. And some of the things are collections of parts, which we call assemblies. And we're going to be talking about assembly, waterfall and agile assembly in 2 weeks. But you got to start with the parts. You got to figure out, well, okay, so these are parts. And of course, these are traditional physical product parts that most of you probably are familiar with. I mean, these are engine parts on the left-hand side, and on the right-hand side of the slide, you see these similar parts only with part numbers. This is what we're talking about. Everything that you write as a requirement, every test case, because remember before I made the argument that test cases were the ultimate level of requirements. Every individual test case is its own part in inventory. So like the ones on the right, you see all the numbers, and all those numbers are there so that we can reuse those parts in the future. In the next series after these 8, I'm going to talk about efficiency. I'm going to teach you how to be super, super efficient in order to operate your business to get a lot of stuff done very, very quickly. All right. These parts are stored in repositories, and probably the most common repositories out there today, Azure DevOps, which used to be Team Foundation Server, Jira, very popular, HP Enterprise, ServiceNow, IBM Rational. These are some of the bigger ones. I mean, there's a lot of solutions that are repositories for requirements. And what they really are is they're inventories of parts. And that's how I want you to think of them as an analyst. I don't want you to just think of them as sentences, but actually unique, standalone, singular parts that can be reused in the future. One of the things that I find interesting is that institutionally, most institutions complain about the fact that they're not efficient enough, but unfortunately, they haven't set up their shop to be efficient. They sort of make that an edict, like, hey, we need to become more efficient, but they don't tell anybody how they want to do it. So I'm going to tell you exactly how you have to do it. You have to have an inventory management system of all your intellectual property, and you have to decide in advance how you're going to number everything. You have to have a categorization with codes and things of that nature. The example that I used in another class was the number 4011. Anybody been in a grocery store and every single product on the shelf has an inventory number? So I was teaching a class at Whole Foods and I used the word 4011. Actually, someone else used the word 4011, not me. I was talking about parts and inventory numbers and someone yelled out 4011. So you get extra credit in the text chat if you know what 4011 stands for in a grocery store. Anybody know? 4011 if you're in a grocery store. I'll tell you what, it's in the produce section. Anybody know what 4011 is? Anybody been grocery shopping? Nobody want to guess? 4011. You're close. Turns out that it's bananas. Carla got it, bananas. So, and what's interesting about 4011 is 4011 is consistent as an inventory number at every grocery store you walk into. So it's not just a Whole Foods number, it's in every grocery store. Whatever your local grocery store is, you can walk in and look at bananas and there'll be a little sticker and it'll say 4011. And as you start looking at all of the different inventory items in produce, you'll see that they all have a number associated with them. And those numbers are cross industry. Like they're not they're open and available to anybody that wants to use them. They're not owned by any particular group. And I have a vision, actually I don't have a vision, I agree with the vision of the object management group, the OMG, that we should have ultimately a standard set of numbers for requirements across every single industry. And of course, each industry is going to have unique requirements, but that's part of what the object management group is there to do, is help create a standard way of numbering all of our requirements as inventory in our intellectual property. Now, why is this important? Well, when you're talking about automation, and you're talking specifically about machine learning, structured machine learning, having an inventory of parts allows the machines to learn faster. And having standard requirements allows the machines to learn faster, which is why at the end of the day, the most important requirements are test cases. So you take a vague generality of a human talking, and then you decompose it or abstract it down into very specifically written statements that ultimately make their way to test cases, which we're going to talk again more about next week when we get into IEEE ears. But we've actually touched on that in some of our previous sessions together. As we develop all these test cases, this is the language of automation. It's how we're going to communicate with our systems in the future, is by using very test case kind of driven statements to make sure that the machines do exactly what we ask them to do. All right, that's it for another day. But along those lines, I want to talk about INCOSE and their rules for requirements, which is kind of really what this is all about. So there's a group, the International Council on Systems Engineering, of which there are many groups: IEEE, OMG, W3C3 or W3C, anyway, World Wide Web Consortium. And they all have different pieces of the puzzle figured out, which is awesome, because really as an analyst, we don't want to try to figure it out ourselves. If anything, we want to leverage everything that is a standard that's available to us and reuse those standards as much as possible. So what INCOSE did, which I think is really cool, is they went through and they looked at a couple of different things. There's a lot of information here, and it's in our short period of time together, it's hard to go through all of it, but we're going to touch on some of this. So I'm just going to show you the headlines, and then I'm going to come back and go a little bit more in depth. So they talked about the characteristics of individual requirement statements. They talked about the characteristics of sets of requirements. And again, a set of requirements is like an assembly of parts. Talked about the attributes of requirement statements. And they talk about rule categories for actually writing requirements, of which there's a lot of different rule categories. So let's go back to this. So at the end of the day, remember that, and I point this out, if you look on the right-hand side of the slide, if you're new to my presentations, you'll notice that it's human, 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 and then intelligence at the bottom. And the blue person, in case you don't know that, that's Microsoft Cortana from the game Halo. That was the only example that I could come up with, since Cortana runs on a lot of Windows machines. The idea is for us to build documentation and requirement statements that allow Cortana to operate independently and be utilized as a mechanism to help us make better decisions. So this is kind of where it's all going. Now, people always say to me, are robots going to take our jobs? And I said, well, no, not really take your job, but they are absolutely going to change your job. That is for sure. What robots do very, very well is operational work. That's what they do really, really well. Where they struggle is in analytical work. Unless you give them very precise instructions, they don't see the world the way humans see the world, at least not yet. Hopefully never. But from an operational standpoint, once you train your robot to do what you need it to do, it can do it 24 hours a day, 7 days a week, 365 days a year, and never get tired. Just give it all the work that you want, and it'll just keep going. How do we train the robot to do this work? Through our requirement statements. Okay, so it's important to know about, well, what do we need to know about these requirement statements? So Cosi went through and they identified 9 things that you need to know about individual statements. Number 1, they need to be necessary. So you don't want to write statements that aren't necessary. They need to be implementation independent. So it says a requirement states what is required, not how the requirement is met. They need to be unambiguous, which is really hard to do. That's a fact. And a requirement statement lends itself to a single interpretation. And as such, the nice part about that is then it becomes a unique piece of inventory. It's complete. A requirement statement is complete in and of itself. Again, unique, discrete inventory. Requirement statement addresses a single thought. It's singular. It's feasible. It expresses something that's inherently realistic. You know, when they always say, hey, make it better, make it faster, make it easier. Is that feasible? It's hard to say. That's not clear. It's not, you know, it's too vague, which we've talked about. Human language is vague generalities. It's nuanced ambiguity. And our job is to make it very specific, i.e. almost like a test case. It's verifiable. That's the testable side of it. It's correct, meaning a requirement statement is a correct expression of the stakeholder expectation. Again, easier said than done. And it's conforming, conforms to standards selected as applicable to the organization. And where do those standards reside? Well, usually they're a part of accounting and operations. Ultimately, at the end of the day, everything that we do as analysts not only has to be technically capable of delivering the solution, but more importantly, it has to tie back to the financial accounting systems of the institution. So an analyst has to be knowledgeable about both sides. They have to not only understand the technology, but more importantly, or just as importantly, excuse me, they have to understand how it connects back to the mothership, which is the financial accounting system and the operating manuals of the institution. Sets of requirements. So when you think about a requirement set, so you have individual items, and then you have collections of items together, which I call assemblies, very manufacturing mindset. And I think that when you're an analyst, I think it's good to have kind of a manufacturing mindset, a product-oriented mindset, because sometimes intellectual property can be really hard to kind of wrap your brain around. So the metaphor of an assembly will help you think in these terms. So you want your requirements to be complete. So it's a complete definition of the stakeholder expectations. A set of requirement statements represents a complete definition. Consistent. A set of requirement statements represents a consistent expression of stakeholder expectations. Again, easier said than done, but the more you design your statements to be parts in inventory and parts of a machine, the easier it is to be able to produce requirements that are complete and consistent. Feasible, again, a set of requirements represents a realistic expression. Bounded. Now, this is where we talk about a set of requirement statements is within a defined scope, a statement of work package, a use case, an epic, or feature. Probably at the end of September, at the end of this month, I'm going to do a short webinar on use cases and explain and show you an example of what a bounded set of requirements looks like. So it's really a collection of test cases in one statement of work. And then structured. A set of requirement statements is structured such that subsets of related requirements can be identified. So again, having an inventory system, a numbering system, allows you to recognize first individual parts and then assemblies of parts and be able to trace downward and upward in either direction. We got Bob online, and Bob has done a phenomenal job on coming up with RTM, requirements traceability. And someday I'm going to try to pull that out of his brain and simplify it and put it up on the screen. But it's pretty amazing. So, and we'll talk about traceability in a future session. And then attributes of statements. So things that just in general you want to know as a designer. And this is kind of interesting because of the creative aspect of what we do. It's not all just, you know, bits and bytes and packets of protocols. There needs to be an alignment with need. It needs to be an alignment with design. So as you go through your process, there's so much that you have to be aware of as an analyst, which again, if you're curious, makes this the most fascinating job in the world. In alignment with evidence, the relationship between requirements and verification artifacts is documented. Again, that goes back to that traceability that we just talked about and requirements traceability. And then priority, which has become sort of the buzzword today. I mean, it seems like in a lot of shops, priority is everything, which again, nothing wrong with that, but that's a big deal. And I think most of you are already aware of that. And then rule categories for writing requirements. There's a whole number of different categories. I think there are 40 rules, but this comes from an older document from the INCOSE standard, and there's an extra 4 in the list, and that has to do with traceability. So the newer version doesn't spend as much energy on traceability. I think they've decided to kind of demarcate that to something else, but I like it because I think traceability is so important to what we're doing as far as assembly is concerned when you're talking about intellectual property. But just some of the major rule categories, and we'll just touch on them really fast. Accurate precision, concision, again, just keeping things where it's not verbose, not wordy, not a lot of extra verbiage, just trying to nail it is in the fewest possible words that you can. Non-ambiguity, there's 6 rules. Well, there's 10 rules for precision. There's 6 rules for non-ambiguity. So there's obviously a lot of issues with non-ambiguous terms. Singularity, there's a lot of focus on trying to make sure that each statement stands alone. So it's saying, well, the requirement should do this and that, or this or that. The idea is just write 2 requirements or write multiple requirements. And that's fine because there's no financial hit. Unlike physical inventory in a warehouse, there's no cost for intellectual property inventory in your database. So you can have as many unique, standalone, simple requirements as you want because there's really no cost for doing so other than just the sheer volume of records. Completeness, realism, conditions, uniqueness, abstraction, decomposition. Again, everything should be connected. That's the hierarchy. And all of these hierarchy systems that you put together really should emanate from your institutional accounting structures. So I'm always trying to get people in the requirements group to go talk to the people in accounting. And so when they come up with a numbering system, it should match what's happening in accounting, not be some unique system that someone has to then build a join file to connect those 2 together. So whatever you're doing in accounting you should ultimately abstract all your requirements numbering system from accounting down to your technology stuff. Somehow it should trace all the way through. Quantifiers, again, just being really clear about how you measure tolerances, same thing, quantification, all these things are very similar. Traceability, again, a big deal just in managing your inventory. Uniformity, again, simplifies inventory, and then modularity, again, simplifies inventory. So again, as we go through this process and as we're kind of going on this journey, I want you to think in terms of discrete, individual statements, the smallest possible piece that you can get down to, which for most of us is a test case. And how do we manage that from an inventory standpoint? And then once you have sort of that structure down, then you can focus on polishing each of those statements, just like you would perfect each part in a machine. So, you know, they design the machine and they got all the parts of the machine, and then they go back and they re-engineer the parts uniquely to make sure that, you know, over time they improve the process, improve the process, improve the process. You can call it Kaizen, you can call it total quality management, call it whatever you want, but that's kind of the vision of what we're trying to do with statements that are requirement statements. All right. There's a product. I got a chance to play with it. I'm very excited by it. It's called QVScribe. And my take on it is it's like having an online editor who is looking at your statements and helping you to clean them up and make sure that as you're building out requirements across your systems, that there's a consistency in the way everything is presented. Because as most of you know, the larger your institution, the harder it is to keep everybody on the same page. And so it's the little subtleties and differences in words and meanings that cause all kinds of problems that show up later in our production cycle. So the idea is to fix everything in the requirement stage when it's just in a written format, make sure that that is as consistent as possible before you then move into all your later production stages. And this tool is a great tool to help you pull that off. Let's see, I have a link to it. Okay, so I'm gonna put a link to it in the text chat. So if you get a chance, check it out. Very powerful tool. It does a quality analysis. So you can set up how you want it to analyze your data, but it uses intelligence, it uses machine learning, and it uses a huge repository of existing documentation. They specialize predominantly in the area of any kinds of products that are involved with human life. So it's a very, if you're building products for like the medical devices industry, or you're building things that you know, are going to affect whether or not somebody's going to live or die, this is a very good tool for that, because precision is so important in those environments. All right, so that's my little piece on that. So that kind of brings me to the end of my 30 minutes. So train the trainer. So what I'd like you to do is, if you get a chance, go out and talk to somebody about discrete intellectual property and rethinking your statements as inventory in the machine. Then once you have your inventory structured, then you can go in and start to polish your diamonds through the INCOSE rules for writing requirements. And if you need help to do that, or would like to leverage a tool that can help you do that, then you can look at something like QVScribe. All right, so that brings me to the end of today. Any questions? We got any questions? We got questions? Hopefully I didn't make your head blow up. No questions, huh? Okay.
I have one.
Yes.
Is the INCOSE, do you need a membership or anything to see what the rules are? Or is that publicly available?
Okay, so I found mine by doing searching. If you send me an email, rfrederick.pmp@gmail.com, I'll send you the white paper that I have.
Okay,
But I do think you have to be a member for like current information, but it's pretty standard stuff, so it doesn't age quickly. It's got a long life, long shelf life. All right, head's still intact. All right.
Richard, just a small question.
Yes.
On the 12th slide, you mentioned realism has it's a one category rule.
Yes.
Is that related to feasibility?
Yeah, I would say so. Yeah. I don't know it off the top of my head, but yeah, I would think it is. I think it is very much related to that. Yes.
All right, cool. That was it.
All right. Somebody asked, oh, Mike, how difficult has it been for you to be both non-ambiguous and concise? Very difficult. It's very difficult to do either of those, and to do them together is even more difficult. What you're going to find out is your conciseness to be non-ambiguous. You're going to have a lot of little statements that you group together, so it'll actually be a set as opposed to one individual paragraph. Yeah, you have to break things into really small pieces. That's the thing. Yeah. Anything else? All right. Well, we're doing this again next week. We'll do the IEEE EARS, the easy approach to requirement syntax, which I've already taught you that, believe it or not, when we did the requirements and testing and how to write a requirement statement, but this is where it actually came from. So this is going to be really fun to show you guys that. So, all right, well, with that, we are done for the week, and I look forward to talking to you guys again next week. If you are looking for the slides and the videos, please just send me an email. Let me get it. All right, so send me an email to rfrederick.pmp@gmail.com. At the top of the slide, you can see it in the black, and just say slides, or, you know, you can say Cosi, you can say IIBA Tampa Bay, and I will get that information out to you today. So, all right, well, thank you all again for taking time from your busy days. Yes, please touch base with the, if you get the chance, please look at our IIBA Tampa Bay. Please join our group. It doesn't cost anything. We do a lot of events. All right, so we are done, over and out.
Thank you.